So in this case, we are going to consider as a continuation from the previous class that we worked with. Remember, we managed to refer some of our basics from our arithmetic, or which is the linear sequences. And as I said, so many ways of our presentation, as we have got our calculations just like what we had before using the Tn, which is An plus B, or using the other formula, you can still determine the nth term. On an arithmetic, what we saw is that for the given terms, you are going to be having the common difference for the given terms that you be having, which is not of a quadratic sequence. Of a quadratic sequence, we won't have such a condition. It'll be something different at all. Let's take an example of perfect squares and so on. 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, where there is no common difference between these terms. So it is not only about not having the common difference. The major thing is that when there is no common difference, you find what is called the second difference. All right, let me put this way. As we are starting something, I do not want to just like, okay, let me have the formulas. Then from those formulas you'll be wondering, where was this formula actually being taken from? Okay, so I want you to just take this one. Let's say we are given 1, 6, 15, and 28 as our terms. We do understand the terms. Their presentation is still going to be the same: the first term, the second term, the third term, the fourth term, and so on and so on. In an arithmetic or a linear sequence, you worked with the common difference actually. The differences that we're obtaining here were the same. But let's check here. Okay, let's find out what is happening. Second term minus the first term, 6 minus 1, which is 5. Then we move on. The third minus the second, 15 minus 6. So we can even just use our calculator here. 15 minus what? Minus 6, which is 9. We move on to the other one, T4 minus T3, which is 28 minus 15, all right? 28 minus 15. There is a difference of what? 13. These differences, they were supposed to be the same for a linear, like what we had before. T1, T2, T3. The difference there was the same. It was our common difference. But this time, as we can see, we do not have that. So what are we going to say? We are going to take these terms as they do not have a common difference, as there is no common difference from what we had before. We are just going to say that is our first difference. That is our first difference. So the first difference shows us the first term, second term, the third term of the first differences. Take note there. Take note there. So we find the difference again, just like the previous case. You were saying T2 minus T1. So of these first difference that we have, we're going to subtract 9 minus 5. There's a difference of 4. The same thing here, 13 minus 9. There is a difference of 4. Just like what we're having, 6 minus this, 15 minus this, 28 minus this. So it's the same thing. 9 minus 5, 18 minus 9. We are having, since we say this is our first difference, this here now represents the second difference from the actual terms that we were given before, that we had here. We found the first and the second. Noticing this presentation, we're going to notice that there is something now that is common on the second difference. That is where now we have got something common. This is 4. This is 4. Whatever that you're going to have here, it was going to be 4, 4, 4, 4, 4, and so on and so on. So thus, if you are dealing or working with a quadratic sequence, there is now a constant second difference. The second difference is the one that you're now referring to, that you're now working with for a quadratic. So we call this the constant second difference. That's where we have got a constant. We had a constant. For a linear, it was just direct for those terms. You're already having the common or the constant difference. But here, on a quadratic, it happens. That part happens on the second difference. On the second difference. That's where we have got a common difference or a constant difference. All right? So knowing this, guys, it is very, very important. Just understanding this. So in short, we can say for a quadratic sequence, we have the second difference, which is common. All right? So that's what we can put this one into conclusion. That's in a quadratic. So in a quadratic sequence, in a quadratic sequence, the second difference, the one that we saw here, that is the second difference, is what is common or is constant. That is our common difference that we're going to have throughout. The second difference. The first difference, it was just something else. Another sequence. But on the second one, it will be the same throughout. Once you see this, you know that it is a quadratic. That's knowing that it is a quadratic. Remember, just like for a linear, when you subtract first term minus the second one, third minus the second one, the fourth minus the third one, you had a constant or common difference there. It was just direct on those terms as they are. But here we must go through the first difference, then the second difference. Once you see this happen, you know that you're dealing with a quadratic sequence. So just like a linear, we need to determine the nth term. So for a quadratic, the nth term formula will be given. Remember our quadratic, when we're dealing with functions, quadratic function y is equal to ax squared plus bx plus c, where a, b, c are constants. So for a sequence now, we are now presenting as Tn is equal to, in place of x, we put n there. So that's an squared plus bn plus c. Just like any other quadratic presentation, any other quadratic equation presentation, where a, b, and c are constants to be calculated. A, b, and c are constants. We must calculate these constants. That's what we have there. We must calculate that. So the question is, how are we going to do it? How so? Okay. If we understand that our A here, just like the presentation of the previous case when we had the A, here the A can be determined from the second difference. It follows that when we had a linear, when it was a linear here, when we had a linear like this, our A was just corresponding to the first term as it is. But here, please take note. Our A will be taken from the second difference. So it follows that 2A is equal to the second difference. So where A is equal to this, where A, B, and C are constants, and 2A is equal to the second difference, which is the constant difference in actual sense. Second constant difference. So thus we can determine our A from there. If we know this, like in this case, our second difference is 4, so 2A is 4. Divide by 2, so our A is what? Our A is going to be 2. This is what I'm trying to say. So if we understand this, it means you are now supposed to calculate the value of B and the value of C. So there we have got methods that we are going to actually use to determine the value of A and also the value of B, depending with your textbook. We are going to see that one. But I'm going to present two ways. You are the one who's going to choose which way that you do understand. So for us to understand this much better, we just need just a normal representation of this quadratic sequence in any way that we can have it. So just like here, remember I said we're going to have T1, T2, and so on. Then we've got the first difference and we've got the second difference. And your Tn is written in the form of an squared plus bn plus c, all right? So the nth formula is this one, guys. But in order for us to have it, there are ways to calculate that. There are steps to have this whole part. So I'm going to work it from the simplest version, then we go to another part. So the steps that we can take, definitely we must find the first difference and the second difference. Just like here, you find the first, second difference. All right, so you must do that. Calculate or find. So let us calculate the first and second difference. First and second difference, just like what we saw. Then we are going to calculate the value of A since 2A is equal to the second constant difference. It is easier for us to calculate the value of A. All right, so we can calculate our A in that case. Since 2A is equal to the second difference, is something that we already mentioned before, that 2A is equal to the what? The second constant what? Difference. So meaning to say we can just calculate it from there. So you'll be able, after calculating A, you'll be able now to calculate B and C. Remember, you're remaining with B and C, which can be calculated simultaneously. Like I said, there are so many ways. I'm going to show you another way. So this one, you are going to solve for B and C. So you're going to solve for B and what? And C. And this is done at the same time. At the same time, simultaneously. That is simultaneously. Okay? Done at the same time. How are we going to do this? By substituting any of the corresponding, any two. By substituting any two in that case. All right. So you're gonna just work with any two terms into the general equation. So this is what we have got here. We have to substitute that back into the general equation. Two terms of your choice, any of your choice. And in most cases, you're going to see that elimination method is going to be best because C is just a constant. So there's no substitute for C. Like there's no substitute here. Here there is any. So you must substitute what is corresponding to the nth value. But as you can see for C, you won't have anything there. So at the end of the day, you see that elimination is the best method there. So elimination is the best method. I'm not saying do not use any other way of solving your simultaneous equations. No, solving simultaneous equations, guys, there are so many ways. So it is a presentation, this one, on its own that you must understand. I'm going to come back here and try to solve one or two problems that we might work with. Remember, we need to find the Tn, the general nth term. You have your A, you have got your B, you have got your C. Substitute, because these are constants. You substitute back into this. But if we consider again another way that we can actually work with is knowing from the basics of our quadratic. Let's say we want to present these in terms of A, there, B, and C. There's another way which we are going to work with. So this way, you go back to the understanding of your quadratic, which is your general term. Remember, Tn is given as an squared plus bn plus c. So here I'm just going to explain one or two things which will not make sense for now, but it's going to make sense later on. So this is what you're going to do. Remember, these are terms being presented. They're just normal terms like what we had here. T1, T2, T3, these were numbers representing these terms. But here I want us to have the same presentation of these terms, to say the first term, second term, but we are going to have it in terms of A, B, and C. In terms of A, B, and C. In terms of A, B, and C. Meaning to say, the first term, T1, when n is 1, you must substitute in place of n. That is what it means. N is 1. So T1 means what? In place of n, substitute 1. Just like the previous case. So where there is n here, we are going to put a 1. So it's just like 1 squared times a plus, there is bn, so it's just like 1 times b plus c in place of n. So T1 is going to be 1 squared, which is 1 times a, which is a, 1 times b, which is b, plus c. So it is going to be written as a plus b plus c. Remember, in terms of, or answers must be given a, b, and c. We must have that. So it follows that using the quadratic presentation, the quadratic equation, we can substitute and thus have the first term as a sequence now. So our first term, just like this one that was given as 1, here it is given in terms of a, b, and c. So it's going to be a plus b plus c. All right, so that's a plus b plus c. Like I said, it's not going to make sense for now, but it's going to make sense later on. Let us move on to the second one. Here we had got first term, second term. So let's say we need to find the second one. N is what? Is 2. So for the second term, it simply tells us that our n there is 2. So in place of n, we're going to put a 2. In place of n, we put a 2 from this general format. So what are we going to have at the end? If we substitute a 2 in place of n, that's going to be 2 squared, which is 4, times a, which is a, plus 2 times b, which is 2b, plus what? C. All right? So this is what you're going to have. That's our second term. So it's going to be 4a plus 2b plus c. Second term in terms of what? A, B, and C. Just like what we had before in terms of A, B, and C. So we move on. The third term, T3. Just like when we have got a number here, which is 15, but we want to know it in terms of A, B, and C. So it follows that this time our n is now 3. So in place of this, we're going to put 3. In place of this, we put a 3. We put a 3. So we simplify. Our T3 is going to be 3 squared, which is 9 times A, which is 9A. 3 times B, which is 3B, plus C. That is what we have there. So that's 9A plus 3B plus C. We move on to the fourth term. Just like that. So at least you must have 4 terms so that it can make sense. The idea of a quadratic sequence here, at least you must have 4 terms. So let's find T4 in terms of what? A, B, and C. So our T4, in place of n, we are going to substitute 4. In place of n. So that's going to be 4 squared times a. This is b times n, so that's 4 times b plus c. 4 squared, which is 16, so that's 16a plus 4b plus what? C, just like that. Just like that. This is what we have. We have our terms of a quadratic. Remember, they were taken from where? A quadratic formula, quadratic presentation. So thus, these terms represent a quadratic sequence. We substituted directly into a quadratic equation. So we are forming a quadratic sequence. So this is what we're going to have, and so on and so on. All right. So we saw that when we find the first difference, it's going to be something that is different here. Numbers that are just different. So it is supposed to be the same thing. As we are working with these expressions, these are expressions. So if we are to find their first differences here, it is not supposed to be the same thing. It is supposed to be different expressions throughout. If we obtain same expression here throughout, then it means whatever that you're talking about here is wrong. Okay? So let's find T2 minus T1. We are subtracting 4a minus a. So 4 minus 1, that's going to be 3a. 2b minus b. So 2 minus 1, that's 1. So it's going to be 1b, of which, guys, 1b is just same as what? As b. C minus c, that's a 0 there. It cancels. Okay? We move on. T3 minus T2. This is where we are now. T3 minus T2. So we subtract the a on its own. 9a minus 4. So 9 minus 4, that's going to be 5a. 3b minus 2b. 3 minus 2, that's what? That's 1. So it's going to be 1b. And c minus c, that's a 0 there. It cancels. As we can see, 3a plus b, 5a plus b, they are different. If they were the same, to say here we also have 3a plus b, it means whatever that we said before there is wrong, because we saw that on the first difference, these numbers are not the same. So therefore, even for these expressions that we have, they are not going to be the same. All right, let's continue. 16 minus 9a from T4 minus, now is T4 minus what? T3. So 16 minus 9 is going to give us what? A 7 there. So that's 7a. 4b minus 3b, that's going to give us a b. C minus c, it cancels out. So that's a 0 there. So it's going to be 7a plus b. So all this is for the what? The first differences. The first difference. As we can see, it is not the same. But if we move on to the second difference, there we must have something that is constant, common throughout. So let's see. All right, let's see that one now and conclude our quadratic. So let us conclude now. So this is what we're going to have. Going to find the differences here. So if we find these differences, that's 5a minus 3a. 5 minus 3, which is what? Which is 2. So that's 2a. b minus b, it cancels out. It's no longer there. That's a 0. So we move on. The 7a plus b is going to subtract this one. So 7a minus 5a, that's 2a. b minus b, that's a 0 there. So as we can see, guys, as we can see here, that on our second difference, we have something that is common. 2a, 2a, constant. We have got the same thing. This is exactly what we want, just like what we saw here. The second difference, this is 4, this is 4, just the same. So we have a constant second difference here. That's a constant or common second difference. So this is where we are saying the 2a is equal to the second constant difference. Otherwise, guys, that is here what we are talking about here. This one. You might be wondering, where is this 2a is equal to the second difference from those steps that I was mentioning before. Okay, so this is our second constant difference, equivalent to 2a, where it was actually taken from. But as we want to consider as it is in terms of the A, B, and C, how can we determine the general term, the Tn? How? So it follows that, all right, like I said, this another way. So in actual sense, you do not need to say when you are given any quadratic, you rewrite in terms of A, B, this and that. No, 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 no. Here, I want you guys to just know whatever that I'm going to use, where it was taken from. Just for you to understand that. So once you understand this, you're going to notice that the 2a here represents what? The second constant difference there. All right? So this is what you're going to do. You'll be given your numbers here, whatever that you are having, guys, as your numbers. That is the only thing that is clear, the second. So you are going to take these terms along this way. All right? Can we just say slanted line? Remember those lines that we had of this. So we are going to take along this way. So meaning to say, we're going to talk about this 2a. We are going to talk about this 3a plus b. We are going to talk about this a plus b plus c. So I want you to follow up this one. If you are using these steps, guys, yeah, you just follow up. All right, at least I just showed you guys where these are coming from, so you're not gonna like be surprised. Well, why are we using 3a plus b? Where was it taken from? This is where it was taken from. All right, so what I want you to do after knowing that this can happen, we can have our 2a, we can have 3a plus b, we can have a plus b plus c. You are going to take this part, all right? So here, just hope this one is not going to affect me. All right, so let's just say we have got our presentation in this format. We are going to say, therefore, 2a is equal to what? The second difference, which is a constant difference there. Yet this one, it is just like what we saw before, guys, here. Second constant difference. Okay. So along this 3a plus b, this one can also be used. So we can see that 3a plus b, it is equal to, when we consider the first difference there, it is the first term of the first difference. Remember, the first difference has got its terms. So we're going to just like, this is T1, T2, T3 of the first difference. So 3a plus b is equal to the first term in the first differences. All right? So that's the first term there. And the first please take note. It is the first term of what? Of the first difference. Or the first differences that we are given there. The first term of that first difference. The first difference, these are the ones, guys, the first difference, these are the differences that we have. So what is here? Like I said, guys, just take this way, the way that it is. Like I said, you take along like this. All right. So 2a, you equate to the what? Second difference. You take 3a plus b, you equate to that term that is on the first difference, the first term. Like here when it was 5. So it simply means like here we've got, these are our first differences, isn't it? So this one is the one that you are focused. So you say 3a plus b is equal to 5. it's an equation that you must solve for b like that. So here, remember, when you substituted, well, I mean, when you took this one, 2a is equal to the second difference, definitely you have to solve for what? For a. You have to solve for a here. So when you now have this a, it's there. So you must solve for what? For b this time. You solve for what? For b, because you already have what? A. So to solve for c, you move along, like I said here, going up in that way. So the last part we're going to take is a plus b plus c. Represent, what is it representing there? It represents T1 from the original sequence. A plus B plus C is equal to T1 from the original sequence. That is what we can see there. From that original sequence that we give, A plus B plus C is equal to T1. Where you solved for A and B before here. Remember, you have got your A, you have got your B, you have got this. A is there, B is there. So you must solve for what? For C this time. Solve for C. So by solving for A, you solve for B, you solve for C, you are done, because these are the constants of your quadratic sequence. Those are the constants of your quadratic sequence. So therefore, we can have, we can just substitute the letter stage here. So this is what we had: number 1, number 2, number 3, so 4. You substitute the constants, all right, the calculated values, substitute, or just replace this calculated values into the what? Into the general term formula, or just the general formula of our quadratic. Tn is equal to an squared plus bn plus c. You have a, b, and c. So you just need to substitute back. It's another way. It's another way. It's another way that you can work with. Here we have another way, which we said, by knowing, just knowing what you're dealing with, okay? Can calculate the first and second difference. You calculate your A from there as 2A is equal to the second difference. Solve for B and C simultaneously by substituting two terms into the general equation. It's another way that we can actually work with. All right, it's a way that you can actually work with. So just because of time, let me just have one problem that we can use, but I did not want to have examples for now. I wanted to have them later on in another class. All right, so this is it for the sake of time, so that we just utilize our time properly. I'm going to take this as our example, because this one, it's already a quadratic sequence. Remember, we already have our quadratic sequence there. So I'm just going to take that one as our example that we are going to use. So taking this part, we already calculated the first difference, the second difference here. All right. We already have these ones. So using these steps, or this method here, because there are two ways, the method is telling us that you must calculate the first and second difference, which we did. We have it. From there, you must calculate A as 2A is equal to the second difference. So our second difference is what? Is 4. So using this way, right, let me put an arrow like this so that we know we are answering this question. So 2A is equal to the second difference, which is 4. Divide by 2 by 2. Our A is what? Is 2. Just like that. So therefore, A is equal to 2. We must solve for B and C simultaneously by substituting two terms into the general equation. So how are we going to do it using this method? I'm going to come to another way. Do not worry. So remember that this is a quadratic sequence that we are dealing with, which we actually do understand that our Tn is given in the form of an squared plus bn plus c, which we actually do understand this. We have got our a, we calculated from that difference. The second difference, we have got our a from there. So we can substitute and have Tn is in place of a. So that's 2n squared plus bn plus c. This is what we have. So as we can see, what we do not have here is b and c. That's why we are saying solve for that simultaneously. So I'm going to substitute the correspond. This one is in your hands the way that you want. So you can use T1. As we can see, our T1 is equal to what? To 1. T2, you use whatever that you want here, that you want. So I'm going to take this. T1 is representing what? 1. T1 like this. T1 is equal to 1. Let me just take 2. Like I said, you must use 2 there. So it is in your hands. Are you going to use 1, the first one, the second one, the third one? It is in your hands. So let's take also T2. As we can see, T2 is what? 6. So our T2 is equivalent to 6. So this is what we have. You substitute two terms. So these are the two terms, T1, which is 1, and this one. Any of your choice there. They're just supposed to be 2. So what does it mean when I'm saying sub? It means when n is 1. When n is 1, answer is supposed to be 1. When n is 2, the answer is supposed to be 6 from the general. But your general part here already, remember, we substituted the 2 here. So our continuation is on this part. So that is the major part that you're going to have because you are to substitute there. So it's going to have a continuation on this part. This is your continuation. So you've got your B and your C to be determined or to be calculated now. All right? When n is 1, let us substitute here. All right? So that's in place of n, the T1 is what? Is 1. All right? Let's start with this one. So 1 is equal. Guys, here I'm not substituting any. I'm taking the Tn, the Tn, the T1 as it is. It is equal to 1. The Tn is 1. Where n here is, where n is equal to 1. Do not be confused. It's just like we have got one thing there, but know which one, which is which there. Anyways, let us just substitute, guys. That's in place of n. 2 in terms of in place of n, substitute what? A 1. So that's going to be 2 times 1 squared plus place of n, that's going to be 1 times b plus c. We have an equation, as you can see. All right, so 1 is equal to, if you simplify this, that's 2 plus b plus c. All right, let's take the 2 to the other side of the equation. It's going to be 1 minus 2, which is what? Negative 1. So negative 1 is equal to b plus c. As we can see, we have got 2 unknown values, b and c. It's an equation that you have formed there. It's an equation that you have formed. You have formed an equation. 2 unknown values at the same time. So working with the second one, where we are given that this time T2 is equal to 6. The whole of the Tn, just like what we had, the whole of the Tn is the one representing 6. So it's just like 6 is equal to when our n is 2. When our n is 2. So in place of n, you substitute 2 there. So that's 2. In place of n, we substitute 2. So that's 2 squared plus bn. That's 2 times n plus what? Plus c. All right. So that's bn. So that's 2b there. bn. Our n is the one that we're substituting, which is what? Which is 2 there. So 6 is equal to, you can simplify, that's 2 times 2 squared, which is actually a 4 times 2, which is 8. Okay, so that's going to be 8 plus 2b plus c. Okay, take the 8 to the other side, it's going to be a negative. So that's 6 minus 8, which is what? Which is negative 2. So negative 2, that's going to be 2b plus c. We've got an equation here. That's going to be our second one. Simultaneous. Back to our simultaneous equations now. Any method that you can use that you do understand, you can use it. But like I said, elimination is the best. Since we have got the part of c, the constant here, which is exactly the same. There is a c here, there is a c, not affected by any number there. So you can work out with that one, eliminate that. Yes, you can use your substitution. I'm not saying it's wrong. Actually, whenever you use your elimination, you are going to even use the substitution. So knowing both methods is actually the best. All right, so let us solve, guys. Taking the first equation, b plus c is equal to -1. Here I've got 2b plus c, which is equal to -2 as our equations. We are going to eliminate c, the part where we are already having the same. To eliminate, that's to remove that part, okay? Get rid of. So to get rid of the c, are we going to add or are we going to subtract equation 1 and equation 2? It is you asking yourself that. If I add, am I eliminating here? Or if I subtract? Since we've got the same sign there, we must subtract. So let's subtract, guys. Equation 1 minus equation 2. All right, minus equation 2. So equation 1 minus equation 2 simply means b minus 2b. That's going to be negative b there. That's equal to -1 minus 2. -1 minus of the formula, this one, subtracting equation 1 minus equation 2. But what are we subtracting there? We are subtracting -2. So be very careful there, a sign and a sign. So negative to a negative is going to be positive. So that's -1 plus 2, which is a +1. That's a +1. So divide by -1. We are solving for b. Remember, not minus b. We must find the positive value of b. So b is a negative there, -1. Remember, we are dealing with a simultaneous equation. We must solve for a. Using any of these two equations, are you going to go back to the elimination? You eliminate b this time, where you must make sure that you have same variables, same numbers that are affecting the b, the coefficients of b, but that is going to complicate everything. But if you do want to work it that way, still one and the same thing. But as I have got the value of b, I can simply substitute in any one of these two equations. Remember, b plus c is equal to -1 from the first equation. And I have the b, which is -1. I'm just going to substitute there in place of b. -1 plus c is equal to -1. So c is equal to what? Taking the -1 to the other side, or simply add 1 both sides of the equation. that was going to give us a 0 there. Okay, C is equal to 0, which is fine. No problem. So we have got A, we've got B, we've got C. Now we're just going to substitute back into our general term, of which here, all right, just for the sake of space, guys, let me just erase this part. So you must go through these, guys. This one, guys, it is in your hands. As you can see, it's quite easier. It is just solving your simultaneous equations from any two equations that you are working with, right? So since here I've got my B, which is -1, and C, which is 0 there, all right? So remember, I've got our B, -1, and our C, which is equal to 0. We can substitute this and say, therefore, our Tn is equal to, remember already here we substituted where we said A is equal to 2. So we're already at this stage. So that's 2n squared plus, all right, let me just write plus, okay, our B is -1, so that's -1n, okay, -n there, plus our C, which is a 0, so that's going to be 2n, 2n squared, plus and minus, that's a negative, so that's -n plus 0, which is, guys, okay, no problem. This is what we have, a quadratic. Same presentation. Quadratic that we are used to, just like a quadratic equation. So the solving part, it lies in your hands. It lies in your hands. Know the steps that you are to take. Know the steps that you are to take. So we saw that from these steps that we are working with, there is an involvement of solving of simultaneous equations, which is fine. The question is, are we going to obtain the same with another way? All right, so let me have my answer here just for the sake. Okay, let me just leave it as it is here. Let's go to the other section. Another way, which is actually depending with your textbooks, guys. But for other textbooks, you see that they prefer you to understand this. You don't need to like go through this. Okay, let me just erase this part because, guys, you might at the end of the day think that whenever you are given a question, you are supposed to start by this. No. Know the formality. This is where it was taken from. What I want you to just know is this part, and this part. Only those three. The rest, ignore. Unless it's just maybe for an introduction of a topic, or maybe a teacher, you want to introduce a topic to your kids. Yeah, you can do that. But for the sake of revision, let us go straight to the answering of the question. With what we had, remember, it's another way that you want to have our answer, just like how we solved this other side. This time, we are saying from this way, we must determine, just like the previous case, the first difference is, guys, second, that one is a formality to be done. But now you are saying 2a is equal to the constant diff, which is exactly just like the previous case. So here I'm not going to change anything. I'm just going to exit it so that we understand that there are different ways, but giving us the same thing. All right. So here it is in terms of the calculation. So that's another way that we are going to have. So remember, 2a is equal to our second constant difference, which is one and the same as what we had before. So 2a is equal to 4. Okay. So divide by 2, it means our a is equal to 2. So you focus with here. Okay, let me indicate it, guys, so that we'll be together here. You focus with this part. This one. These are the ones that you're focusing with on this way. So the 2a, you equate it to the what? Second difference, just like before. Then on the first difference is there. The 5, which is your first term of these first differences. We say this one, it represents 3a plus b. We saw from that indication. And the 1 of the first term from the original sequence that we had represents a plus b plus c. That's the only part that you just need to know this one. Once you know this, guys, you're done. This is it that I was writing here. 2a is equal to the second. You solve for a. All right? Then you move on to 3a plus b. Because you're done on this one. All right? You're done on this one. We move on. 3a plus b must or is representing what? 3a plus b represents the first term of the first differences, which in this case, it represents 5. From the sequence that we are dealing with, 3a plus b is equal to what? To 5. But remember, we calculated our a. We have it. We have the value of a. So simply substitute. In place of a, so that's 3. We're going to substitute here. So 3 times our a, which is 2 here. Okay? Plus b. So we must solve for b now. As it is. As you can see, the only unknown there will be b. So you must solve for b. We have an equation. So 3 times 2, all right? So there is an equal to here. There is an equal to here. All right? So let us simplify and solve for b. 3 times 2, that's 6. All right, so we've got 6 plus b, which is equal to 5. All right, so take the 6 to the other side. It's going to be what? A negative there. 5 minus 6, or just subtract 6 both sides of the equation. So that's our b is 5 minus 6, which is what? Negative 1. That's our b. So we have our a, which is 2. We have our b, which is negative 1. The last part is to calculate the value of c, to solve for c by taking what? A plus b plus c being equal to t1 from our original sequence. Our t1 is 1 here. So you take this as it is. All right? A plus b plus c equal to what? To our t1, our first term. And what is our t1? That is 1. Remember, you had already solved for a and for b. Just substitute. You have those values. So in place of a, you're going to substitute. We have got this one, which is 2, plus we have got our b, which is negative 1, plus c is equal to 1. So now we must solve for what? For c. Okay? So that's it. 2 plus negative 1 is just going to be positive 1 there. Remember? Plus and minus, minus. So 2 minus 1, that's 1. So 1 plus c is equal to 1. Take this 1 to the other side, or simply subtract 1 both sides of the equation. That's 1 minus 1, which is what? Which is a 0 there. So our c is equal to 0. After finding these constants, what you're going to do is to substitute them as they are in that general formula for a quadratic. Remember, our Tn is equal to what? An squared plus bn plus c. This is a presentation, guys, that I just want you to know. Ways that you can use. So you're going to substitute. Remember, our Tn is equal to an squared plus bn plus c. So that's our Tn is going to be a, which is 2. So that's 2n squared plus our b, which is -1. So plus and minus, guys, that's a negative there. So it was going to be -1n, which is simply -n, plus our c, which is a 0. There's nothing that you are adding there. You are adding a 0. There's nothing, guys. Just leave it. Just leave it. There's nothing that is being added. So we have our Tn in its simplest form. So as we can see, it's mathematics, guys. It is a subject that is very broad enough that you can choose ways of how do you want it to be done. The way that you're going to calculate now, it is in your hands. Are you going to opt for this? Or are you going to opt for the first one that we worked with here, where you had to solve the simultaneous equations in application? It is in your hands. But as we can see, we have got the sum and the term, same general formula at the end of the day. So I want you as an individual to work out now as many questions as you can. Use anyway. If this is the one that I just had now is the best, then you continue that one. If the first one is the best, then you use that one. You must have same answers. So it can be a way of a revision. Maybe you're a group of learners that are using our videos for revisions. You try different ways. Do not use one way. Try different ways so that when you are discussing, you can have something to discuss on. So I want you guys to do as many questions as you can. We shall meet again in the other class.